Okay, so as I said, we're going to fill in this table and let me show you the calculations that I did by hand. All right, so let's pull this together. And as you can see, I have recreated this table in a hand document, and there's a lot of little calculations that go into this, so I suggest that you work it sort of methodically. And I'm going to start over here. So for each cell, I've taken each of the individual scores, and I've gotten the sum of x for that particular cell. So this is the sum of x for males who are in the funny condition. Once I have the sum of x, I go ahead and get my n in the cell 1, and that is equal to 3 because I have 1, 2, 3 scores. And then I'm going to go ahead and calculate my cell mean, which is 8. All right? So I repeat that for each of the 4 cells that I have. I can do the sum of x for my 3 female in the funny cell and get my cell mean by taking sum of x, 18, divided by the 3 scores, and then I get my cell mean of 6. And I'm going to repeat that in this third cell. 6 plus 5 plus 5, I get my sum of x of 16, and I can create my cell mean of 5.33, and I do the same for the female, not funny. So that's my 4 cells that I've calculated. And I've tried to go ahead and shade the areas that are basically row and column and sort of totals. So these are not cells, but we're going to need to calculate all of this information for use in our formulas. So I've shaded it to show you those aren't cells. These are our 4 cells, but these are going to be important calculations that we do. So let's start with our row. We want to calculate our row means. We want to calculate our row ends, and we want to calculate our row sum of x because we're going to need those. So to do my funny row, I'm going to take my sum of x for the male funnies, who are 24, and then my sum of x for my female funnies, who are 18, and divide that by 6 because I have 6 scores in the entire row. I have 1, 2, 3, 4, 5, 6. So that's going to give me my mean of 7 for the row. My sum of x is just going to be, for the row, is going to be 24 plus 18. So the sum of x for this and the sum of x for this is going to give me the sum of x for the row funny. I can do the same thing for the not funny. So I'm going to take, for this row here, I want to take this sum of x of 16 and add it to this sum of x, which is 22, in order to get my row sum of x. Then I can divide that by 6 because I have 1, 2, 3, 4, 5, 6 people in this row, and that's going to give me my row mean of a 6.33. So remember go back if you're getting confused and remember what these numbers stand for. The average attractiveness rating for people who had the funny saying on their t-shirt was a 7 out of 10. The average attractiveness rating for the people who had the blank t-shirt, who are not funny, was an average of 6.33 out of 10. Alright, now I'm going to do my column means and sum of x's. So here I'm working with males. So I want to get my male column mean. So first I get my male column sum of x, which I take my 24 here and my 16 here, and I add them together, and I get my column 1 sum of x of 40. Then I can divide it by 6 because I have 1, 2, 3, 4, 5, 6 people in that column, and that's going to give me my mean of 6.67. Same thing with female column. I'm going to take my sum of x equals 18, add it to my sum of x equals 22 for the column, and get sum of x of 40. Then I can divide 40 by 1, 2, 3, 4, 5, 6 because n equals 6, and I get my mean of 6.67. So I've calculated the average attractiveness ratings that males gave the photos versus the females gave the photos. All right. Now I'm going to do this sort of final piece here, and this is sort of the grand totals, and I can calculate many things here. Probably the most important things that I need to calculate in this are I need to know my total N, how many total people participated in my experiment. And so I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my N equals 12. Then I also wanted my grand sum of x, which is going to be adding together the sum of x of all the cells, which I've done right here for you. So I take the sum of x of cell 1, which was 24, add 18, 16, and 22. So 24, 18, 16, and 22. So I get a grand sum of x of 80. That's where this figure right here comes from. All right. If I want to get my grand mean, I can do that. Divide by 12 and then get the grand mean. So the only thing that I actually haven't shown you in terms of calculation here is your grand sum of x squared, which I've calculated to equal 552. So what you're going to do there is you're just going to, let me pull out my calculator, clear it out. You're basically just going to square each of these and add it together. And I did that in my head. So I took 8 squared, 64, plus 9 squared, 80, which is 81, plus 7 squared, which is 49. So I did that for these raw scores. Now I'm going to do it for these. Plus 36, plus 49, plus 25. Now I'm going to go down and square these. 36 plus 25 plus 25, plus these final ones. So 49 plus 64 plus 49. And I get a grand sum of x squared of 552. So grand sum of x squared just means I've squared all of my raw scores and then added them all together. So that's 552. All right. Now we're going to start calculating our sums of squares rows, sums of squares columns, and sums of squares interaction, and then sum of squares within. So for each of these, I just want to put it up here, and I want you to look at the formula first, which I've just transferred over, and then here it is with the numbers pulled in. So I want the sum of x squared for row 1. This is row 1. Sum of x is 42, and I'm going to square that. And then I'm going to add the sum of x for row 2. This is row 2. Here's sum of x. So 38, and then I'm going to square that, and then I divide this value by n, the number of people in the row total. So our row n equals 6, so I'm going to divide that by 6, okay? And then from this full value, I subtract the grand sum of x, which is 80, squared over big N, total number of people, right? That was 12. And so I've done those calculations for you. Go ahead and pause the video, do the calculations, and make sure that you're coming up with sums of square rows of a 1.34. For sums of square columns, we repeat this kind of process, but we just use the column information here instead of the rows. So I take my column 1, sum of x, 40, square that, plus my column 2, sum of x, which is also 40, square that, and then divide by the number in the column, which was 6. Okay, so 6 people per column. So we're going to divide by 6. And then we're going to subtract the same grand sum of x squared that we've just calculated here. So we know that that value is 533.33 because I've just calculated it. So imagine this, actually this value of 40 squared plus 40 squared divided by 6, which is 1600 plus 1600 divided by 6 equals 533.33. So they're exactly equal, and we get 0 for sums of squares column. There's no variation from the grand sum of squares. Okay, and then we can do our sums of square interaction. Okay, so for this one, I'm grabbing my sum of x from cell 1, row 1, column 1, my cell 1 from row 1, column 2, sum of x, etc., etc. So if you go back up to the calculation, you're going to see that we have a 24, an 18, a 16, and a 22. Let's go back up here, right? 24, 18, 16, 22. Square each of those and then divide by the number in each cell. Okay, this is that in that you have to be really careful with. It's the number in each cell. There's 3 in each of those cells, so we're going to divide by 3. And then we're going to subtract the grand sum of x squared over n, which we've calculated several times now. And then remember, in this particular interaction, sums of squares, we're also going to subtract the 2 sums of squares that we've already calculated, rows and columns. So the 1.34 and the 0 that come from our sums of square rows and sums of square columns. And so once I put all those numbers in, take a moment, pause the video and do that. And what you should end up with is a sums of squares interaction of an 11.997, which you can round to 12 if you want to. Alright. Then finally we have our sums of squares within. So for this calculation, you do your grand sum of x squared and subtract the interaction, basically that interaction value that you just put together above. Alright, so we go back up to our working table and we have the grand sum of x squared. We've calculated at 552, so we're going to go ahead and pull that down, 552, and subtract this entire value here, which we calculated right here, which should be 546.67, and that equals 5.33. So once you've done all of this, you want to go back in and put it in your source table. Okay. So we have now calculated all of these sums of squares and we can put them into the source table. You'll notice that I also just added all the sums of squares together to get the 18.67 for the sums of squares total. So degrees of freedom for row is r minus 1, the number of rows minus 1. We had 2 rows, so 2 minus 1 is 1 degree of freedom. For the sums of squares, the degrees of freedom column, it's c, the number of columns, minus 1. Okay. So 2 minus 1 is 1 degree of freedom. The interaction is row times column degrees of freedom. So we have 1 degree of freedom for interaction. And then our within sums of squares is going to be our row, number of rows total. So we had 2 rows times 2 columns, so row times column, times in per cell minus 1. So we had 3 people per cell, minus 1 is 2. So we end up with a within subjects degrees of freedom of 2 times 2 times 2. 2 rows, 2 humor conditions, 2 genders, and n minus 1 per cell, so 3 participants minus 1 equals 2. So 2 times 2 times 2 is 8. For total degrees of freedom, we can do that 2 ways, right? You can take n minus 1, where n is the total, big N, the total number of people in the experiment. We had 12 people total, so n minus 1 is 11, and you can double check yourself because the total degrees of freedom should equal all of these added together. So 8 plus 1 plus 1 plus 1, 11. Now we're into the simple calculations. Now we can do mean squares. So for mean squares, to fill in our mean squares blocks, we take our sums of squares divided by our degrees of freedom. So 1.34 divided by 1 is 1.34. 0 divided by 1 is 0. 11.997 divided by 1 is 11.997. 5.33 divided by 8 is 0.67. So this is a very simple mean square, sort of calculating it, sums of squares divided by degrees of freedom. Okay, now we have the information that we need to calculate or fill in our obtained F value. So remember, for all of these F values, you're going to take your mean squares between divided by your mean squares within. So we have a mean squares between divided by our mean squares within, 0.67. So the 0.67 is going to be your denominator on all of your F values. You're just going to take your sums of squares, 11.997, or mean square 11.997, and divide it by 0.67, and you get 17.91 here. You take 1.34 divided by 0.67, and you get a 2, rounded to 2 here. 0 divided by 0.67 is 0. So here are your F obtained values. So these are the values that you are going to hypothesis test with. I've gone ahead and again gone to the F table at the end of the book and figured out what our critical value for comparison is for each of these. Now you do need to look in the back of the book. Remember that all of these are the same, but the reason that they're the same is because the degrees of freedom for row, column, and interaction are the same. There are instances where you might have, say for instance, if you had 3 humor conditions, your degrees of freedom here would be 2. So your critical F value would be different because you'd have to go in your F table over 2 and then down 8. Okay, instead of here you've gone over 1 and down 8. But for this it's pretty easy because you have the 5.32 either way. So if let me see if I still have that F table up. I do not. Well, you'll just have to look in the back of your book. So what are you doing for hypothesis testing? Which of these which of these are rejecting the null hypothesis? So we want to compare 2 to 5.32. It is not. It is less than that number, and we're looking for it to be greater than or equal to. So we have to retain the null hypothesis. There is no effect of humor. For our F obtained of 0 compared to 5.32, we want to retain the null hypothesis. There is no effect on attractiveness by gender. But what we have with the interaction effect is 17.91 F obtained is going to be greater than a 5.32. So we actually have a significant value here. So for the interaction effect, we are going to reject the null and accept the alternative. There is a significant interaction. Okay. Once we have that kind of information, the next step in a Factorial ANOVA is actually to go ahead and try to graph the results using the cell means so that you can get a sense of explaining your data and your significant interaction. So I've gone ahead and done that for you here. We're always going to graph our results on a Factorial ANOVA so that we can visually see what's happening to attractiveness ratings. So here are the attractiveness ratings. They range from 0 to 10 was the absolute highest. And so this is the mean for females who saw the funny picture. This is the mean for the males who saw the funny picture. This is the mean for the males who saw the not funny picture. This is the mean for the females who saw the not funny picture. Okay, so there are no significant gender effects. There's no significant difference between attractiveness on males and females, and we know that because if we take the if we take these two values and average them together, and these two values and average them together, they're going to be the same. We saw that on the cells. We also know from our F-test that we cannot say that there's a difference in what in the funny means and the not funny means. But what there is a significant interaction, and we can see that here. Anytime we see this kind of crisscross, we're typically going to see a significant interaction. So in this case, you could explain that for females, they rated the not funny person more attractive, but for males, they rated the funny person more attractive. Okay, so that's kind of a way to explain that interaction. And then finally, for effect size, you can get an effect size for each of your F ratios. And this is again eta squared, but we call it partial eta squared because we've divided the between subjects variability into 3 different effects. And so we call it partial eta squared for the individual row, column, and interaction. And to calculate it, you just take your sums of squares for that particular row, column, or interaction and divide it by the sums of squares, row, column, or interaction plus the sums of squares within. For our humor and gender example, the only significant effect is the interaction, so we would only calculate the interaction effect size. So we would take then for the interaction, the sums of squares interaction, which was 11.997, and divide it by the sums of squares interaction plus the sums of squares within, which is 11.997 plus 5.33. So we have a partial eta squared of a 0.69. So at this point, you might go ahead and practice using slides 63, 64, and 65, or the equivalent. It's possible that these are numbered a different way in the Moodle. So if you can look at this and see how far you can get in filling in your source table here with practicing this problem by hand. And we'll come to class on Tuesday with any kind of questions you have about the videos and the practice that you went through. Do remember that you can always rewatch a video if you're not understanding what I'm talking about. Go and look at it again, pause it, make sure you understand before you move on, and I'll see you in class on Tuesday.